All right. So last class we started talking about understanding the uncertainty embedded in the supply chain. So to understand this, we introduced the concept of demand uncertainty versus implied demand uncertainty. So demand uncertainty refers to the uncertainty within the demand for a certain product. However, the implied demand uncertainty depends on what sector of customers that the company is intended to serve. Right? So, in other words, the implied demand uncertainty is determined by the competitive strategy of the company. So, for example, if we decided to provide maintenance parts, so then the implied demand uncertainty depends on which sectors of customers we're serving. So if we're serving customers who demand maintenance parts on the fly, so in other words, emergency settings, then the implied demand uncertainty would be much higher than the regular settings. So one part of the uncertainty in the supply chain comes from demand uncertainty. And we talked about various elements of demand uncertainty, including the variety of quantities that customers require, the lead time by which companies are supposed to deliver their product to customers. So as the range of quantities required increase, and as the lead time decrease, we expect demand uncertainty to rise. Similarly, if customers want a higher variety of products, or we require a higher level of service level, and as the product innovation increases and the number of channels we provide customer with products increase, these are all causes for the demand uncertainty to increase. So, and now we talked about the correlations between other attributes of products with demand uncertainty. So, in general, if we see the demand of a product having low uncertainty, then it generally corresponds to products that has a lower profit margin. And because the uncertainty is low, then generally that implies we would be able to forecast the demand relatively accurately. And because uncertainty is low, that means we're able to match supply with demand more accurately, which means one, we will have fewer stockouts, and the other one will have fewer leftover inventory at the end of the season. So you'll see less season-end markdowns for low implied uncertainty products. And on the other hand, we have products with high implied uncertainty, so which will correspond to high margin, high error, and high stockout and markdowns. So, for example, if we're talking about flour as a product, which kind of attribute do you think flour fall into? high or low? Low demand uncertainty, right? Flour is a day-to-day food item. The demand for flour should be relatively stable over time. So then you can see that the profit margin of selling a unit of flour is very low as well, and you'll be able to forecast the demand relatively accurately. On the other hand, if we have, a fashion product, a new clothing design, that would be falling into the high implied uncertainty criteria. Right, so that's why in apparel industry we see a lot of seasonal markdowns at during Christmas or end of any selling season. So on the other end, we have supply uncertainties. So supply uncertainty comes from the randomness involved in the supply process. So machine breakdowns and yields from production processes. And then if the product quality is poor, then it will also lead to an increase in supply uncertainty. And then if we have a small amount of supply capacity, or the capacity is inflexible, meaning that it's not capable of dealing with a variety of requests, or that the production process is still evolving, then that means the supply side uncertainty is high. So we would also observe that the supply uncertainty is highly correlated with where this product is on its life cycle. Right, so imagine if a new product is being introduced versus a very mature product. Right, so which one would have higher supply uncertainty? New products would have higher supply uncertainty because the manufacturing process is still immature. It might have a lot of uncertainty. So when, if we introduce a new product in the consumer electronic industry, then the production process tends to be unproductive and the yield tends to be low, breakdowns tend to be high. Now, the uncertainty from both the supply side and the demand side can be combined onto this uncertainty spectrum. So on the left side, we have very predictable supply and demand, so low uncertainty. And on the other end, we have very high uncertainty on supply and demand. So this would correspond to maybe a new electronic device, and whereas the other end we have, maybe salt or flour at a supermarket. And somewhere in between, we may have another product, maybe existing automobile model, whereas if we introduce a new model, maybe it will fall more on the right side. So after understanding that there is uncertainty in the supply chain, either from the demand side or the supply side, that presents a challenge for us to what can we do to best match these two? Right, so in order to best match these two, we first need to understand what are the capabilities in the supply chain, and then think about what are the things we can do to align the uncertainty with supply chain capability. So to talk about supply chain capability, there are two concepts that are very, very important for you to understand. One is the responsiveness of the supply chain. So basically, the responsiveness of the supply chain is the ability of the supply chain to respond quickly to changes, right? So that could be changes in a variety in the order quantities, or meeting short lead time, or handle a large variety of demand orders for different kinds of products, or the ability to build very innovative products with very short life cycles, and meeting a high service level. So in creating the suitable supply chain, we need to match the responsiveness level of the supply chain with the appropriate level of uncertainty in the supply chain. Now, basically, if the supply chain is more uncertain, that means we need a more responsive supply chain. Right, so then the question is, do we want to have a supply chain that is as responsive as possible? You know, push it to the farthest responsiveness as possible. No? Somebody said no. Why not?
There might be a high cost involved.
High cost. So usually responsiveness, for example, if one way of introducing responsiveness is to say we use a fast mode of transportation. Right? So you know that using FedEx one-day delivery is much more expensive than use USPS ground. Right? So on the other end of responsiveness, we have efficiency. So supply chain efficiency is basically talking about how little cost can you use to deliver the product to customers. So in other words, the higher the cost, the less the efficiency. And so for every supply chain, we're basically finding a balancing point between efficiency and responsiveness. And to do that, visually we can create the so-called cost responsiveness efficient frontier to give us basically describes what is the lowest possible cost we can achieve for a given level of the responsiveness. So this cost responsive efficient frontier will look like something like this graph. And of course it varies depending on the specific application, but the idea is as we increase cost, right, going from low to high, we'll tend to see higher responsiveness. And if we reduce responsiveness, then we can also reduce cost. So that means for a company, if a company, since this is cost responsive efficient frontier, that means this line responds the best possible scenario. Right, so you will not find a company, say, with cost efficiency and responsiveness somewhere here. Right, so this is for a certain level of responsiveness. This is the lowest cost possible. That point is on the efficient frontier. So this point is impossible. So in reality, you will see companies that's here. So if a company is here, that means there is an opportunity to improve both measures. Right? I can, for example, moving from here to here, right? In this direction, I'm both reducing costs and improving responsiveness. The other scenario is this company is already on this efficient frontier. That means I cannot strictly improve the performance on both measures, right? In order to improve one, say I want to improve responsiveness, I have to sacrifice cost. So which direction makes sense depends on your competitive strategy. Now, again, so responsiveness is a spectrum going from the lowest level of responsiveness and the highest level of efficiency to the lowest level of efficiency and highest level of responsiveness. And usually, one way of evaluating responsiveness is through lead time. So we can be, this can be evaluated by lead time. So lead time is basically the time between customer placing an order to the time that customer actually receiving the order. Right, so the shorter this lead time, the more responsive supply chain is. Now, so on this spectrum, we have highly responsive supply chain. So for example, 7-Eleven, who actually replenish their inventory in both in the morning and during the lunchtime and in the dinner. So you will see a variety, the changing mix of inventory in a 7-Eleven store throughout the day. And on the other hand, so 7-Eleven, by the way, is very responsive. And on the other hand, we may have, integrated steel mills that are highly efficient, but they can only respond to demand changes in a very slow pace. So, question. Think about Costco. Where do you think Costco would fall?
Highly efficient.
Somewhat
Highly efficient. Probably more on the efficient side than on the responsive side. Right. So they sell a limited variety of products in large quantities. So you can get better prices for the limited selection they have, but you cannot have more choices as in you would get in other retailers. Okay, so now we have understood for supply chain, we can observe based on our competitive strategy, we have a resulting uncertainty level, right? And then for supply chain capability, we have a spectrum to choose from highly responsive to highly efficient. Now, this question?
Yeah. Also, does the type of whether I have a push or a pull system affect my responsiveness?
Good question.
It should, logically, it should.
It should.
Having a push system means I'm more responsive because I'm always having products coming in. But at the same time, having a push system means that I have a set order of or a set of products that are being delivered, so it might be harder for me to change one while that keeps on happening. So that's why I'm asking.
Mm-hmm. So, okay. Push versus pull system. Which one is more responsive?
Probably. I would say push.
You'd say push? Why is that?
Because I'm just thinking of examples, but I'm thinking, I'd say Zara. Zara has a push system, and it's pretty responsive.
Right.
So it deals with uncertainty, with high responsiveness, but having a push system means you have uncertainty.
Mm-hmm. So, any other wants to comment on this?
No, for me, pull is like you get demand. The demand is not uncertain. So push basically, in push there is more uncertainty.
Mm-hmm.
So
So, depending on the characteristics of demand, let's say, if you have a high demand uncertainty, do you think you should more likely implement a push or a pull system? Pull system, right? So, and then for high demand uncertainty, should we have responsive or efficient supply chain? Responsive. Yep. And of course, there are companies like Zara. There are other ways to deal with supply efficiency versus responsiveness. For example, for some categories of products in Zara, their supply chain is actually more efficient than responsive. You know, for example, their basic T-shirts, those ones with less variable demand, and that allows them to be more efficient without losing much of the demand. The other part where the demand is highly uncertain, they use a more responsive supply chain. So yes, there is a correlation between push-pull and responsiveness and efficiency. Good question. Okay, so basically, when we try to achieve the so-called strategic fit, what we're trying to do is to match the level of responsiveness with the level of implied uncertainty in a supply chain. And if a mismatch exists between what the supply chain does particularly well and the customer demand, then the company will either need to restructure the supply chain to support competitive strategy or change its competitive strategy. Say, I want to actually serve this other segment of customers. And the way we do that is we want to assign roles of different stages in the supply chain so that we can have more flexibility to play with so that the appropriate level of responsiveness can be achieved. And we also want to make sure that all the functions in the supply chain, you know, whether it's a production department, logistic department, and sourcing department will maintain a consistent strategy to support the competitive strategy. So basically, where we want to be is in this zone of strategic fit. Right, so on the y-axis, we have responsiveness spectrum going from efficient to responsive. And on the x-axis, we have demand uncertainty going from low to high. And we want to make sure that for when demand uncertainty is low, then we can match it with efficient supply chain. Whereas when demand uncertainty is high, then we match it with responsive supply chain. So, by the way, so this matching responsiveness and uncertainty is basically matching our supply chain strategy with competitive strategy, because the implied uncertainty is determined by our competitive strategy, whereas the responsiveness is determined by our supply chain strategy. And so in reality, there are many things we can do to ensure this strategic fit. Right? The reason why we have a lot of levers to play with is because we have different parties in the supply chain. Each can be configured to match with the whole strategy. So, for instance, in order to achieve the same level of implied uncertainty or the same level of responsiveness of a supply chain, we might choose one strategy to let the retailer absorb most of the uncertainty, and the retailer therefore is very responsive. And the manufacturer and the supplier both are very efficient, and they don't need to deal with a lot of uncertainty. On the other hand, we may let the retailer absorb only a small portion of the uncertainty and let the manufacturer deal with most of the uncertainty, and let the manufacturer's production process be very responsive. So actually, these two supply chains, if you remember in the last class, we talked about a couple examples of furniture makers. Right? One is sort of like IKEA strategy, right? Make to stock, and the other one is Ethan and Allen, where they make customer furniture. Now, can you fit these two companies into supply chain 1 and 2?
First one is
One is
IKEA.
Stock is supply chain.
One is IKEA. First one,
One
IKEA.
is
IKEA.
IKEA. And the other one is Ethan Allen. Right, so in IKEA, so they have this modular design of their furniture components, which is all the inventory is held at the retailer's gigantic floor space, and usually when you go to IKEA, you find a lot of inventory, and because of that, through building inventory, they are able to absorb any uncertainty in customers' demand. And because of the modular design, the manufacturer and the supplier has a very relatively simple jobs, right? So they only need to produce a limited selection, limited variations of components, and because of that, they're able to maximize efficiency. And another benefit from this structure is the benefit of reducing transportation cost. These modular designs are very compact, they stack very well in trucks, so we can maximize truck space. On the other hand, Ethan Allen, the retailer holds very minimum inventory. Right? So the demand uncertainty is absorbed by the manufacturer, who is able to process a lot of varieties of customer orders. Right? So most likely the manufacturer has a flexible production process, and you can reconfigure the machines to change maybe the fabric, the color, and so on and so forth, so that the uncertainty is absorbed here, whereas the supplier and retailer are likely to be more efficient and responsive. All right, so now to summarize the distinctive features of efficient versus responsive supply chain. So these two would serve different goals or different competitive strategies of a company. So for efficient supply chain, we would like to supply demand at the lowest cost. Whereas responsive supply chain, the concern is not so much about cost, it's about to being able to adapt to customer demand most quickly and most in a best fitting way as possible. And in terms of product design strategy, for efficient supply chain, the goal is still to minimize cost. Whereas in the responsive supply chain, you will also see modular designs, which allows us to do the so-called postponement of differentiation. And so that's when, through modular designs, we're able to shorten the time that customer has to wait when they order a custom-made product. And then for pricing strategy, efficient supply chain usually corresponds to low profit margin products. So meaning that the price is not a primary driver for customer demand. Price is a primary driver to customer demand. So, and then on the other hand, responsiveness of supply chain is able to charge higher price and enjoy higher margins. And then for the manufacturing strategy, in terms of capacity utilization, for efficient supply chain, in order to reduce cost, we would like to utilize the capacity, the production capacity, as much as possible. So you will usually observe very high utilization. Whereas in responsive supply chains, because we want to respond quickly to changes and fluctuations in demand, we need to set aside some capacity. So utilization is not as high. And then inventory strategy, there's much more of a need to use buffer inventory in responsive supply chains versus efficient supply chains. In terms of lead time strategy, responsive supply chains, one goal of responsive supply chains is to aggressively reduce lead time. Whereas this reducing lead time is only important for efficient supply chains if they can do so within limited cost. Supply strategy, so sourcing, in terms of sourcing, efficient supply chains focus on the cost of suppliers and also quality. And responsive supply chains will also look at how responsive the suppliers are, how flexible their production processes is, what's their reliability in addition to cost and quality. And so another consideration is, so in most companies, especially companies with larger scale, we may serve multiple customer segments. Question?
Does Apple comes under a responsive supply chain?
What do you think?
I find two qualities, like it's efficient and also it's responsive.
So, I think they combine a lot of different strategies. One is they definitely is a quality differentiator, and they do enjoy a high profit margin. Right, so in order to maintain that position, they have to be, sufficiently responsive. And the cost concern, since their profit margin is not so high, the cost concern is not as much. But as they, expand more and more, they do seek efficiency, through, for example, sourcing from Chinese manufacturers for their component supplies. Any other questions?
Could we say that having a more responsive supply chain means I can dictate my price better as opposed to having an efficient one? Just because I can respond to demand faster means maybe I'm more responsive than my competitors, which means I can dictate the market as opposed to being efficient and competing with other
companies where cost is now a huge concern for the customer.
Right. So there is a correlation between how much you can charge and how responsive your supply chain is, but the causality doesn't quite work that way. Right? For example, no matter how responsive you make your flour supply chain to be, you may not be able to charge that much for flour. So it's ultimately driven by what the customer wants. Right? So sometimes you're able to differentiate by being super responsive. Sometimes the market limits itself.
So it depends ultimately on the product.
Exactly. Okay, so achieving strategic fit, another consideration is that a company could have many types of products that's aimed at serving different segments of customers. So you could see some companies have higher, more luxurious brands and versus a more low price brands. So these are to basically serve different segments of customers, and they have vastly different supply chain structures. And going back to the example of Zara, some basic products with stable demand, they may serve it with efficient supply chain, whereas highly volatile demand is served with responsive supply chain. And tailoring the supply chain to achieve strategic fit, sometimes requiring sharing the operations for some links in the supply chain. So links could be, a facility, could be a link of transportation, the connection between different members of the supply chain, and having separate operations for other links. Right, so for example, maybe we'll have different products sharing in the same facility in a company, but we differentiate the shipping of these products to serve different segments of demand. Whereas in other kinds, we could have products share the same transportation mode. Maybe they're all through ground transportation, maybe they're all 2-day or 5-day delivery, but some products are assigned to flexible production capacity and some are to regular production capacity. And all of these have different implications for their responsiveness versus efficiency. So I already mentioned the notion of changes over the life cycle of a product. So depending on where this product is on its life cycle, it can have very different characteristics. And as a result, it requires different supply chain configurations. So in the beginning stages, demand tend to be very uncertain, and supply may be unpredictable. So, when we introduce a new product, we know very little whether customers will be able to accept this product and how many of them will be. And the supply chain technology may not be perfected, so it can have a lot of breakdowns and uncertainties. But the upside of being in the early stage is there is little competition. So, which basically give you a monopoly status, allowing you to charge very high margins, high prices, and this time is crucial to gain market share. And of course, product availability is very important in this phase as well, because you want to capture as much market as possible. And here, cost is often a secondary consideration. So for these stages, would we need, what is the implied uncertainty? High uncertainty. And what is the correct supply chain configuration? Responsive. And then if we let the product go to later stages, the demand will become more certain, and supply will be also more predictable. And then most likely the market is saturated, or there will be more competition. So then the profit margin will be decreased. And as a result of the competition, price is now a significant concern for customer choice. So in this case, the implied uncertainty is low, so we want an efficient supply chain. So to summarize, we talked about understanding the level of implied uncertainty in a supply chain, which is determined by the competitive strategy of the company. And we talked about how to understand supply chain capability, going in the spectrum from efficient to responsive. And then we talked about how to match these two, right, to achieve strategic fit. And then we talked about different tactics, different methods to use to achieve this strategic fit when you are tailoring the supply chain. And then in terms of, since we talked about supply and demand uncertainty, there are several levers we can utilize to reduce uncertainty or reduce the impact of uncertainty. One is capacity. Right, so basically we could increase capacity or increase the flexibility of capacity to reduce the impact of uncertainty. Right, so usually that will lead to more responsiveness. The other lever, we have inventory. So inventory is one of the most important levers to deal with uncertainty. Right? It helps us to better match supply with demand. And generally, the more inventory you hold, the more responsive you are. Although that doesn't mean you can observe a company, with a lot of inventory and just say this company is very responsive. And then time. So this means the lead time and the flow time of production and supply. So basically, if the customer is willing to wait for longer, that means the implied uncertainty for the supply chain is lower. And if we're able to provide the products in the faster fashion, then the impact of uncertainty is lower. And finally, we have information. So we can build on information infrastructure. We can acquire more data so that we know more about demand, we know more about supply, we know more about other parties in the supply chain. All of these will help us to better understand the demand, so perform more accurate forecast, so in which basically reduces the uncertainty we're facing. And then information also allows different parties in the supply chain to better coordinate with each other and therefore better cope with uncertainty. So these are levers we can utilize to reduce the effect of uncertainty. And generally, if we invest, we can choose to invest in one or more of these levers. And if we invest in one, then that reduces the need for us to invest in others. So which one do we invest in? It depends on various factors, such as which one is the most cost effective for me to do. Okay, so we talked about strategic fit. Basically, we want to match uncertainty with responsiveness level. And in a supply chain, there is also consideration of where the strategic fit applies to. Right? So for different levels of strategic fit, this would apply to a different set of players in a supply chain. So basically, in one extreme, we would have each type of operation just mind their own business and making sure their own strategy fits with the uncertainty they're facing themselves. Right? On the other extreme, everyone in the supply chain will talk about matching the whole supply chain strategy with the entire uncertainty faced by the supply chain. And of course, the broader the scope, the better the performance of the supply chain, and the more challenge there is to enforce the strategic fit. Okay, so when we talk about scope of strategic fit, we talk about the extent that of functions within the firm and stages across the supply chain to integrate the strategy and with the aligned objective. So we're going to ignore the one extreme of every operation minding their own business and start with intra-operational scope. So intra-operation scope means that each stage of the supply chain will devise their strategies independently, and their goal is to minimize their local cost. So, for example, we may have the logistics or transportation department of the company. They may set their goal to minimize transportation cost. Right. So that, of course, will have implications to other stages, other functions in a supply chain. Right. So it could result in, various levels of inventory and result in different levels of responsiveness for the whole supply chain. And realizing that would be an issue, we may want to expand the scope to intra-functional scope. So then the supply chain functions. So if we're talking about the sourcing, manufacturing, inventory and transportation departments will align their strategies to minimize the total functional cost. And so the weakness, so this eliminates the weakness that we had before with intra-operational scope. Right now, we would only use a certain mode of transportation if it doesn't create extra burden on, say, the inventory department or the production environment, or the burden it creates on them is justified by my saving. All right, so, but a weakness of this intra-functional scope is that the different functions within a firm may have conflicting objectives. So, for instance, if marketing departments may focus on revenue maximization, whereas the manufacturing and distribution may focus on cost minimization. And so that is a problem. Why?
Because sometimes both goals are in exact opposite direction.
Mm-hmm.
Like the production department wants tonnage and the marketing department want to deliver the product in time. So both are in opposite.
Right. So, one could lead to more responsiveness and generates, say, more demand and more higher revenue, but that could lead to a less efficient production process, so increase the cost of the manufacturing function. So in order to reconcile this conflict, we can increase the scope of strategic fit and go to interfunctional scope. So in interfunctional scope strategic fit, all the functions will work together to develop strategies in order to maximize the company's profit. All right, so now has all the problem been solved? Are there any additional remaining conflicts?
Last time we said that to measure the success of a supply chain, we don't measure the profit at every stage or every company. You have to look at the surplus of the whole supply chain, and that's how you figure out if you're being profitable or not. So maximizing company profit does not necessarily mean maximizing surplus, supply chain surplus.
Right. That's exactly the point. So basically, if we're allowing each company to maximize their own profits, then a likely consequence of that is the most powerful company will just harbor all the profits and make sure that everyone else will do whatever makes this company profit the most. But of course, that may be devastating for the other companies, and in the long run, bad for the supply chain. So, on a higher level, we want all the companies, all the stages in the supply chain, suppliers, buyers, and retailers will work together to maximize the supply chain surplus or the supply chain profit. So one example is so Walmart could, and Procter & Gamble Walmart used to plan the promotion separately from Procter & Gamble, and one negative consequence of that is the timing of their promotion could lead to, Procter & Gamble, when they run a promotion, Procter & Gamble would face a huge spike in the demand, and they have to do overtime, they have to expand their production capacity in order to fill that demand. So that harms the profitability of Procter & Gamble. So later on, they expanded the strategic scope and worked together to plan these promotions so that neither company is hurt by these promotions and other strategies. And so basically, that's the largest scope in terms of the supply chain structure. One other thing to include in the scope is the temporal scope. Right? So nowadays, the customer preferences are constantly changing, which means you might need to adjust the supply chain strategy to fit with the ever-changing customer taste, and even change your strategic competitive strategy to fit with the current need. All right, so, and in the end, I just want to mention some new challenges that in the past decade companies are increasingly facing. So one is that the product variety is ever increasing. And so consumers are demanding more and more customization and more varieties to fit their individual taste. And another implication of that is the shrinking of life cycle. Right? So we have more and more electronic and digital innovations, and every year or two they will go obsolete. So all of these, the reduced life cycles and greater product variety, will increase the uncertainty and also reduce the time window that companies have to deal with this uncertainty. And the second one is globalization. Right? So when the supply chain expands to different countries all over the world, then we need to deal with the uncertainty embedded in all of these locations. So the overall uncertainty increases, and we need to deal with complexities like exchange rates, uncertainties, the changes in the different markets, segments, and the price of oil, and so on and so forth, will all increase uncertainty. And then there is also a fragmentation of supply ownership, so which means that supply chains are less and less so-called vertically integrated. Right? So vertically integrated supply chain means that we may have a company basically managing the operations of everybody in the supply chain, and information is completely shared between different companies. In recent years, we see a reverse trend of that. So companies are more protective of their privacy, and the ownership becomes smaller and smaller. And an implication of that is there is even more need for coordination between different supply chain members. And because of the fragmentation, information sharing is ever more challenging. So that the goal of maximizing supply chain surplus is more challenging to achieve. And of course, technology and business environments is changing faster and faster, and which would force the companies to rethink their supply chain strategy and even competitive strategy in a faster pace. And finally, we have these extra considerations, right? So considerations for supply, the environmental responsibility, sustainability, social responsibility in the supply chain, right? So customers now care more and more about where the product is coming from, whether it's sustainable, whether it's fits the labor law, and so on and so forth. So these all provide impose constraints on companies. So making the basically, the choices are more limited for companies, but also creates opportunities for companies to differentiate themselves in actual venues. Any questions about this chapter? Nope, let's take a break. Shall we move on? So the next topic is supply chain drivers and metrics. Now, as we have already discussed in the beginning of this course, the ultimate goal of supply chains is to maximize supply chain surplus. And a premise that we and all supply chains are functioning on is that maximizing supply chain profits is implying that we're maximizing supply chain surplus. Now, so in order to facilitate improvements in supply chain surplus, that would generally mean that the financial performance of firms in the supply chain would be improved. Now, so in this chapter, we're going to look at some key measures to evaluate financial performance, and then we're going to discuss some major drivers for these performance and what are their metrics and what are their impacts. Okay, so one of the most important financial performance measures is return on equity. So this is a measure on the return of investment by shareholders. So this is calculated by dividing net income by average shareholder equity. And then another financial measure that's related is return on asset. So that measures the return earned on each dollar invested in by the firm in its assets. So to calculate ROA, we divide earnings before interest, so by the average total assets of the company, and the earnings before interest is net income plus interest expense times 1 minus tax rate. So to look at an example for the financial data of Amazon and Nordstrom in 2013, we can see that so for Amazon, the net income is 274,000 in and then to calculate return on equity, we divide net income by the average shareholder equity, which is here. So this is 9,746,000, and this leads to a return on investment of 2.81%.
Isn't the average of stockholder equity, shouldn't the total be divided by the number of shareholders or stockholders in the same?
So no, average means average over time. So, and then you can calculate similar values for, so this is for Amazon. And for Nordstrom, return on equity is this number divided by this number. So 32.04%. And then return on assets for Amazon is, so we first calculate the earning before interest, which is calculated as net income 274K plus the interest expense 141K multiplied by 1 minus tax rate, and tax rates were given as 35%. And this divided by the total asset value, 4159K. So 0.91% return on assets. Compare with this value for Amazon, Nordstrom has 8.86% return on asset. So it seems like on both of these measures, Nordstrom is doing better than Amazon. Alright, so, and from these we can calculate some other values. So one is return on financial leverage. So return on financial leverage, so financial leverage is basically the amount of debt or securities that the company uses to buy more assets. So this value is capturing the amount of return of equity that can be attributed to financial leverage, and this can also be calculated as ROE minus ROA. So in Amazon's case, 2.81% minus 0.91% is 1.9%, and Nordstrom has a 28.05% ROFL. And some other financial measures are one, profit margin. So profit margin is basically your earning divided by the total sales revenue. Earning before interest divided by revenue. So the profit margin is much higher at Nordstrom, 6.91%, than the 0.49% at Amazon. And the asset turnover is equal to our revenue divided by total assets. So basically, asset turnover is trying to measure what is the capability of the company to translate my asset into earning power. Right, so the higher the asset turnover, the more this asset is translated into earning power. And we can see asset turnover rate is slightly higher at Amazon than Nordstrom. Another important measure is account payable turnover. So to understand that, first we need to define account payable. So basically, account payable is the money owed by a business to its suppliers, which is shown as a liability on the company's balance sheet. So basically, this is to say, my supplier had given me these products, and for those products I owe them this much money, and I'm supposed, for account payable contract, I'm supposed to pay them back within a certain amount of time. So account payable turnover, APT, is equal to the cost of goods sold divided by accounts payable amount. Right, so for Amazon's case, cost of goods sold in 2013, where is it?
So
Cost
second
of
one
goods,
from the top.
yep, this one. And then divided by the account payable,
Liability.
this one. So for Amazon, this means account payable is 54181K divided by 21821K equal to 2.48. So what does that mean? It means that Amazon basically effectively what's that?
Owes less money to, when you compare it to Nordstrom, it means it owes less money that it has to pay for its suppliers.
Right. So it has to pay less frequently to its suppliers. And if we translate it into the amount of time that suppliers was waiting for their money to be paid, this is, 52 weeks is in a year, and divided by 2.448 APT means that basically Amazon is holding suppliers' money for, on average, 20.97 weeks. And that's very attractive because the time you can hold this, the longer you can hold this money for, the more you can use it to finance your operations. The same measure for Nordstrom is equal to 5.25, so much higher than Amazon. Now, the return on asset can also be written as a combination between two ratios. One is the profit margin, one is asset turnover. So for Amazon, the profit margin of Amazon turns out to be 0.87%, whereas the profit margin of Nordstrom was 11.07%, and the asset turnover for Amazon was 1.85. The turnover for Nordstrom was 1.50. Now, remember that in previous we would calculate the return on assets was higher for Nordstrom than for Amazon. And if we break them down more, it turns out even though Amazon had more asset turnover, it ended up having less return on asset because the profit margin was much lower. And then the asset turnover measure can be further decomposed into three components: the receivable turnover, accounts receivable turnover, inventory turnover, and property, plant, and equipment turnover. So account receivable turnover is revenue divided by the money in account receivable. So basically, how quickly is the company able to collect money of its sales? And then the inventory turnover is how quickly the company is able to sell its inventory. So it's equal to the total amount of goods sold, total cost of goods sold, divided by the average inventory level. And then we have PPET is measuring the value generated from investing in property, plant, or equipment. And it's calculated as revenue divided by these investment amount. So for Amazon, we have ART equal 15.62. And so, which means comparing to its account payable turnover, this is a much higher amount, meaning that Amazon is actually able to collect money fairly quickly and pay money at a much slower pace. And so this is translating to about 3.33 weeks on average they're able to collect the money from sales. Inventory turnover for Amazon was about 7.31 times, and the PPET was about 6.8 times. So inventory turnover translating to how long inventory sits in inventory is 52 divided by 7.31, translating to about 7.11 weeks is about the average time product sits in the inventory. And so turns out Amazon achieved a higher asset turnover rate than Nordstrom by turning its inventory faster and generating more revenue per dollar invested in PPT. So if you compare inventory turnover for Nordstrom was about 5.46, and PPET for Nordstrom was about 4.71, whereas ART for Nordstrom was about 5.16. Another measure is cash to cash cycle. So this is measuring how quickly can the cash that enters the process as cost will be returned as collected revenue. So this cash to cash cycle has three components. One is the amount of time that the cost spends in inventory, and then the amount of time the cash is waiting in account receivable to be collected. And then there is a negative part, so the amount of cash you're able to recover from account payable is going to reduce this cash to cash cycle. So to calculate these numbers, you can calculate them as this negative sign is inside of this bracket. So weeks payable is 52 divided by account payable turnover. Weeks in inventory is 52 divided by inventory turnover. And weeks receivable is 52 divided by account receivable turnover. Now, we have calculated all these numbers for Amazon. So in fact, the weeks payable for Amazon was 20.97. And weeks in spending inventory was 7.11. And then weeks spent in account receivable was 3.33. Which is equal to 10.53, minus 10.53. So what does this value mean? It means that in 2013, Amazon was able to collect its money from the sales of products more than 10 weeks before it has to pay its suppliers. So again, this is a very attractive feature. The smaller cash-to-cash cycle means that you're able to liquidate your cash, your money, faster. So these are just summaries of the financial measures for Amazon and Nordstrom, and we can see that C2C for Nordstrom is a much higher number. And if you look at different industry sectors, you will tend to observe very different financial metrics for different industries. So for example, pharmaceutical companies tend to have a very long C2C cycle compared to consumer electronics, which has a very short C2C cycle. And on the other hand, pharmaceuticals have a much higher profit margin. Now, so these are the financial metrics that will actually show up on the financial statement of a company. There are another two measures for financial performance that don't show up on financial statements. One is markdowns, and the other one is lot sales. So basically, they don't show up on financial statement because they're not actually the money received from sales, but they are sort of a measure of the opportunity that's lost. Right, so markdowns measure the amount of money that you lost from selling your product at a discount, and lost sales represent a missed opportunity from having more product in stock. So both markdowns and lost sales will tend to have a very large impact on the supply chain performance and on the financial performance of the company. And companies that strive to manage their supply chain well and match supply with demand accurately is actively striving to reduce these two measures. So reducing markdown is to reduce oversupply. Lost sale is to reduce undersupply. Now, in this next section, we're going to identify some of the key drivers that affects supply chain performance and the financial performance of the company. And so our goal is to understand how these drivers will explain the difference in financial performance between firms such as the Amazon and Nordstrom example we just saw. So generally, most companies will begin from top and going down. We will start with a competitive strategy and then decide what the supply chain strategy should be, which will specify where the supply chain would fall in the efficiency and responsive spectrum. And then the supply chain then will use these different drivers to reach the performance level the supply chain strategy decides in order to maximize supply chain profits. So, and then these drivers can be classified into logistical drivers, which includes facility, inventory, and transportation. And we also have cross-functional drivers, including information, sourcing, and pricing. And we'll talk about each one in details in a little bit. And even though this framework is most of the time seen from top down, each of these drivers will have an impact to the upper levels. Right, so the changes in, say, the transportation policy and transportation mode selection may have an impact on the supply chain structure, on a supply chain strategy, and sometimes even competitive strategy. So take the IKEA example. So what they're trying to do is to deliver furniture items at a low cost and at acceptable quantity. Right, so then they use modular design to an unassembled furniture to carry components in inventory at the retailer warehouse. So, and the low component variety and the stable replenishment orders facilitated by these modular design is then translated to suppliers being able to have much cost efficiency. Then, which implies that in a sourcing structure, we would want to focus on suppliers with possibly more cost efficiency than responsiveness. And then another implication is for transportation. So because a lot of the uncertainty is absorbed at the retailer level, and the customer mostly would be responsible for their own delivery. Transportation is also focusing on more efficiency than responsiveness. Okay, so let's look at these drivers one by one. Now, first one is facilities. So in facilities, we're basically looking at decisions regarding what does the facility do, where should they be placed, what's their capacity and how flexible they ought to be. And all of these decisions will have a significant impact on supply chain performance. So supply chains are constantly making these decisions on the maybe like month to month or year to year basis. So for example, over the year, Amazon has expanded its facility network. Right? So they have built a number of warehousing facilities all over the country and all over the world. And second driver is inventory. So inventory is part of the firm's asset. And it's one of the most important levers for the company to trade between efficiency and responsiveness. And when we look at inventory, we need to consider a lot of inventory related to either raw material, working process, finished goods within the supply chain. And then we have transportation. So basically, transportation is important in the supply chain because we want to move the product to our customers. Right? So then we need transportation to move inventory from upstream suppliers all the way through different segments to the end customers. And so then there are a lot of decisions to make in each of these links. Right? So basically what kind of modes we should be choosing for transportation, which routes should they be taking, and what kind of structure, what kind of transportation policy are we using. And so these three are the logistical drivers. And for cross-functional drivers, we have information. So information, as we had discussed previously, is the collection of data and its analysis related to all of the logistical processes and all of the facilities. And so, in a sense, information is perhaps one of the most powerful drivers of supply chain because it affects all the processes that we have talked about. And then we have sourcing. Right, so sourcing, again, we basically determine the upstream structure of the supply chain. Who do we source from, for which products, which activity is to be outsourced, and which activity is to be performed in-house, and so on and so forth. And sourcing decision will also affect where the company stands on the spectrum of responsiveness. Right, so, one example is Motorola. So they decided to outsource its production from manufacturers in China. So that it increases its cost efficiency, but because of the long distance of transportation, it initially decreases responsiveness. So, which is often not ideal. So in order to compensate for the loss of responsiveness, they have introduced the air travel for transporting products from China to other parts of the world. And that example is also one example to see how these drivers will interplay and be combined together to improve this performance. And then pricing is also very important because not only it directly affects our revenue, but it also dictates customer behavior. Right, so, airlines and hotel industry are examples that are constantly using algorithms to manipulate their price and to differentiate customer sectors so that they can maximize the return. Okay, so we're going to look further into each driver and look at their role, their metrics, and their impact. So, facilities. In supply chains, we use facilities mainly either for production or for storage. And you can view retail stores also as a form of storage site. And by changing facility design, we can increase the responsiveness, right? And this is usually by increasing the number of facilities or make them more flexible or increase their capacity. And so to illustrate the effect of number of facilities on responsiveness, imagine we have a region, right, where basically, let's assume that we're Walmart. We want to think about how many stores to build in this region. Right, we can build one store, which means my average distance to customers is about this far. An alternative is to build maybe many stores, which would mean on average I only need to go this far to reach a customer. So this reduced distance will tend to increase the responsiveness and perhaps also induce more demand. So there is also a correlation and trade-off between facility decisions and the costs involved in inventory and transportation. Now, if we say increase the number of facilities, how do we expect the inventory and transportation costs would change?
Increase inventory and decrease transportation costs.
Increase inventory costs and decrease transportation costs, right? So it increase inventory costs because there is more locations for inventory, and for each location there is less of economy of scale. And for transportation, the costs tend to decrease because the distance that need to travel is decreased. There's a more subtle trade-off between transportation to deliver products among these different locations and then from these locations to customers. But for now, let's just say the transportation costs would decrease. And then increase the flexibility or increase the capacity of the facility would tend to decrease inventory costs and response time. Why is that?
Because I'm able to store more items in one place
versus if I increase the capacity of one location, versus distributing my inventory across different facilities. So that means I'm paying more for one facility, but less for all the inventory.
Right. So basically, if we increase flexibility, that and or the capacity of a facility, we reduce the impact of uncertainty. Right. So, and the more impact, more uncertainty, more need for inventory.
Also, if we increase the flexibility, like IKEA does, it uses its store as both a warehouse and a retail store. So I'm making my facility more flexible. So I'm decreasing my inventory cost because customers are coming and buying directly from my store or warehouse.
Mm-hmm.
But I increase my facility cost because now I have my employees and so on and so forth.
Right. Okay, good. So, so one example for the flexibility story is, so Honda was, they really emphasized on building flexible production process in each of their facilities. So basically enabling them to produce both SUVs and small sedans. So that was very helpful to them during the economic downturn because that was one period of time where there was a drastic shift of customer demand from larger vehicles like SUVs to small sedans. Because they had this flexibility, they were able to quickly shift their production capacity from SUV to sedans and suffer little loss. Okay, so when we talk about facility decisions in supply chains, what were we talking about? One is capability, right? So basically, are we building a flexible capacity, or we're dedicating a fixed capacity to a particular process? Are we combining these two in a particular facility? And then so the trade-off between flexible and dedicated is flexible is more responsive but more costly. Dedicated is less responsive but more cost efficient. And then the capability of a facility can also be product focused or functional focused. So a product focused facility would be basically this facility will manufacture product A, and I will perform processes that needed in each steps of producing product A. And the functional focused facility will basically say this facility is dedicated to carry out this one particular process that may be a part of the processing steps for product ABC. So basically, the product focus facilities tend to provide more expertise on a particular products at the expense of functional expertise that comes from the functional focused facility. Then we have one of the most important decisions for facility design is the locations. So basically, where to put all the company's facilities and how many of facilities to build. So the trade-off is between centralizing facilities to a larger place and with farther distance with the customers, or decentralize into smaller facilities. Each will cost a little more, but will enable more responsiveness. And when we make facility location decisions, we also need to consider the environment and the macroeconomic factors. For example, are workers around this facility possessing the skills that I need to carry out the production or any other functions in this facility? And then what is the labor cost, and whether there is a space in this region for my facility. Is this actually close to my targeted customer group, and whether it's close to other facilities of the same type, which could possibly lead to demand cannibalization. And another decision is capacity. So basically, how much of production function or storage capacity is the facility going to hold. And another decision is whether we should be building excess capacity based on our demand forecast. Right, so if we're building an efficient space, less excess capacity. If we want to be more responsive, more excess capacity. But of course, that's more costly. Another consideration is demand allocation. So basically, if I'm building facilities in the same region, how do I allocate demand from here? Do I allocate demand from here to this facility or to this facility? And this is perhaps more of a more relevant decision nowadays because of online businesses. And as demand conditions change, demand allocation decisions should be revisited and more frequently than the location and capacity decisions. So how do we describe or evaluate the facility-related decisions? And so before we discuss each decision, bear in mind that none of these single decisions can indicate whether the performance of a facility is good or not. Usually we need to look at multiple or all of them to have an accurate picture. So for one, we can look at just capacity of a facility, right? So that usually is indication of how responsive this facility is. And utilization measures how what is the fraction of capacity that is currently being used to satisfy demand. And so utilization will affect both the cost of processing a unit of order and the related delay. Right, so high utilization usually means higher delay. And we can also look at the processing time, setup time, downtime, or idle time in a facility. So the utilization should usually be limited ideally be limited only by demand, but not by the setup times or downtime. And then we have quality losses in the facility, which is self-explanatory. So, and then we have production cost per unit. So these cost measures the average cost to produce a unit of product, and then we have the theoretical flow time or cycle time of production. So this is the theoretical cycle or flow time is the time that the product will spend in the facility, assuming there is no delay. Of course, that is almost never true in reality. So then we have the actual average flow or cycle time, which is basically the theoretical time plus the amount of delay. One may also look at product variety. So basically, how many types of products do you process, produce, or store in a particular facility? And the usually the production cost and the flow time will tend to increase as the variety increases. And then we may also be interested to look at the volume that is contributed to the top 20% of SKUs and top 20% of customers. So top 20%, you can measure this by the 20% of product that generates the most revenue for you. So basically, the most meaningful, the most important products. So this will give you an indication of the importance of a particular facility, and also an indication to you that how much of the facility should be efficient process and which should be a dedicated process. So average production batch size is the average number of product, average amount produced in each production batch. And large batches will tend to generate a more efficient, cost-efficient process, but of course it will increase inventory. And production service level, this is the amount of time or the fraction of production orders that are fulfilled on time and in full. And so usually we set a target for production service level ahead of time, 90% or 95%. Okay, so moving on to inventory. So inventory exists in supply chains because of the common mismatch between supply and demand. And there are many other specific reasons for inventory to exist. So, for example, this mismatch could be a result of economy of scale. Right? So, maybe it's more economical to transport products in large batches or produce products in large batches, and as a result, you have to hold inventory that cannot be immediately consumed. And you could use inventory to reduce costs and possibly for the same reason. to, there is also perhaps intentional mismatch at, for example, a retail store where if you anticipate that demand is going to go up significantly in the near future, then you would want to build up your inventory in anticipation in order to smooth the ordering process when the demand increases. And that preparation by accumulating inventory actually will reduce costs in the long run. And that also has an effect of improving product availability. And building inventory will affect what asset is held and what costs are incurred, then the resulting responsiveness provided in a supply chain and the flow time for the material. Now, so imagine if we're looking at apparel supply chain, supply chain that sells a shirt, let's say. What is the effect of holding high levels of inventory?
Inventory holding cost.
Inventory holding cost, yes, will increase inventory holding costs. What else?
Economy of scale.
We're able to explore some economy of scale, okay. Anything else? Availability. So we're reducing possibility of stock out. Anything else?
Cash flow.
Cash flow. Explain more, please.
Okay. The more inventory means lower cash flow.
More inventory means lower cash flow. You mean lower cash on hand?
Oh yeah.
Yeah. You commit more capital in inventory, in the forms of inventory, which has a certain risk of
Product might be small.
the product may be
Outdated.
oversupply, basically. So the overall trade-off is, for one, increasing inventory would generally make the supply chain more responsive to customer demand. So as more demand come in, holding more inventory would mean that I will be more capable of satisfying them. A higher level of inventory would usually mean a reduction in the production and transportation cost, because that higher levels of inventory would mean that I'm more able to explore the economy of scale embedded in batch production system, embedded in large quantity of transportation using semi-trucks, and these are less costly per unit speaking compared to small vehicles or a more flexible production process. But of course, holding more inventory would mean that the inventory holding cost is increased. The inventory has also implications on the material flow time. So the material flow time is the time between the point of entry of a certain material or a certain product in the supply chain to the point when it exits. And another terminology we're going to use here is throughput. So throughput is basically the rate of which we're able to sell products. It's slightly different from demand, right? It's because if you're out of stock, then throughput will be capped, or demand rate can be higher. So the implication of inventory on material flow time or throughput can be captured through Little's law. So Little's law, this is a famous mathematical law that specifies the relationship between number of products in a system, the amount of the rate of which demand comes in or throughput is set at, and the amount of time that the material spends in the process. So inventory is equal to throughput times flow time. Now, which means if I have, 100 units of inventory and my throughput, the rate I'm consuming inventory is, say 3 products per day, then the flow time would be let's say, not 3 times, 10 products per day. Let's make it easy for myself. And then the flow time should be 100 divided by 10 equal to 10 days. Alright, so another implication of this is if we reduce flow time to, say, 5 days, that means in order to satisfy the demand at the same rate, we only need to hold 50 units of inventory. So generally, more inventory means more material flow time, and vice versa. So, components of inventory. So basically types of inventory. One, we have cycled inventory, which is the result of either producing products or transporting products or purchasing material products in large lots. And this is generally to utilize economy of scale. So cycle inventory, the amount of cycle in inventory as a result of economy of scale is usually a function of lot size decisions. So basically you would determine, say, each lot I want to produce or I want to transport 100 products. I say 100 products per truck, and then I sell, 10 products per day. So that means we could transport every 10 days. Right? So we place an order every 10 days to take advantage of the economy of scale of the truck. So the larger the lot size, the higher cycle inventory. Another function or another category of inventory is safety inventory. So safety inventory is a result of uncertainty. Now, basically, outside of what we expect to happen, we have a demand forecast, but if in case the reality exceeds what I expect, I might want to hold a little extra, and that is called safety inventory. So how do we determine the amount of safety inventory to hold? That's by trading off the cost of carrying too much, which will lead to loss of markdowns or loss of profits, versus if I hold too little, which will be opportunity cost of not selling, not meeting demand. All right, so another type is seasonal inventory. So seasonal inventory is due to variability. So this is as a result of economy of scale. This is as a result of uncertainty. And the seasonal inventory is as a result of variability. But this is anticipated variability. So it's not really uncertainty. You anticipate that demand will go up in the next season. So like Christmas time is coming, I'm a toy seller, and I know my supplier cannot give me so much product at one time. So for the couple months before, I'm slowly stocking up inventory. So the inventory I have to hold for a couple months' time is seasonal inventory. So in some cases, if you may have the choice of building more capacity instead of buying seasonal inventory, which one makes sense depending on the trade-off between the cost of these two options. So an additional factor that affects the level of inventory for basically any of these categories is the desired level of product availability. So this is what we call service level. Right, so if I want to be able to serve my customer 95% of the time versus 50% of time, 95% of the time would mean I need to have a much higher inventory level than if I only need to satisfy them 50% of the time. So again, what is the appropriate level of product availability depends on the cost related to holding more inventory and the cost related to losing a unit of customer demand. So how do we evaluate inventory systems? One is to look at C2C cycle time. So we already explained how to calculate C2C cycle time, and it's basically the duration between purchasing inventory and selling and receiving the money for that sales of inventory. Average inventory level, so basically over time, how many units inventory do you expect to see in your facility? Inventory turns, what is the ability for you to sell inventory and how quickly can you sell them? And products with more than a specified number of days of inventory. So basically, what percentage of products have stayed in my inventory for, say, more than 30 days. And usually if this number is high, that can indicate two things. One is oversupply. So I stocked up too much, basically. Or there could be some justifiable reasons. So maybe I'm building up seasonal stock. And then average replenishment batch size, basically the measured in SKUs, what is the average amount in each replenishment order. And this measure can be estimated by basically if you have different order cycles and your cycles change, the inventory level in each cycle changes, and this average replenishment batch size can be approximately measured by differencing between the maximum and the minimum levels of inventory between cycles. And another one is average safety inventory. So safety inventory is the amount we hold. Remember, we're holding extra. So basically, instead of estimating based on the difference between maximum and minimum, we're averaging the minimum numbers. So this number would be the amount we're holding extra for safety reasons. The amount of seasonal inventory, basically the inflow of products exceeding its sales in each planning cycle. Fill rate, the percentage of demand that I'm able to fulfill on time and in full. Fraction of time out of stock. So basically the percentage of time that a particular product is out of stock. And then obsolete inventory. So for a product that has a shorter life cycle, this would be an issue. You would have an obsolescence date for the product, and the inventory that's older than an obsolescence date is considered to be obsolete. All right, any questions for this part? If not, let's stop here today.
Yeah, that's a trade-off. You start stacking up. If your supplier is
Measure something. That is what I was asking. Like to what person you are able to forecast it, or to what person you are able to implement it, or what? What you're saying is after we did everything, after the order place we can calculate, but this is the anticipation. No. The metrics what I did is some metrics. What heading was this point. One is I use to determine how the performance of the system is. So performance of the inventory on the entire supply chain. So like for the first part, like time location. So for location, like she said, how you measure location is going to affect the supply chain. So what you do, you'll find how efficiently they are able to deliver the product on time. Like if you put a location here in Dearborn and when you put in some other location, so if your customer base is much more towards Dearborn, so what you do if you are going to increase one facility in Dearborn, so you'll put in Dearborn, you won't put it in some other place. So that is one matrix, like how your location